Hello everybody, so today we're going to be talking about an algorithm called the Bellman-Ford algorithm. Now what this algorithm does is basically you put a graph into an edge list, and then it helps you find the shortest path from one node to another. So let's visualize how it works first and then see how an implementation would look like. So first let's draw a graph. So let's do let's draw the edges first. Then maybe like this. Oops, we don't need these two. Okay, so here we have a graph, and let's number these nodes so that it's easier to talk about this thing without having to point. So here we have nodes 1, 2, 3, 4, 5. Easy enough to remember. Now, since we'll be calculating the shortest distance, then obviously we need side lengths, right? So let's say this one is 5. And then 7, 3, 1. I know that doesn't make sense, but let's just pretend it does. So, and then 2 and 2. So, say we're going to start. So, how the algorithm works is basically, say we're calculating the shortest length between node 1 and any other node. So, we start off with by writing the distances from 1 to each of the nodes that it is connected to. So we start off with 1. So obviously the distance from node 1 to node 1 is 0. And then, so here is node, this distance is 5, and then 3, since like the edge is 3. And then we have 7. So let's just write this down here. Okay, and then basically what the next step is we go from each node, and then we go to each node that node 1 touches, and then we go through all the nodes that those nodes are connected to, and then we try to minimize distances that way. So we can see that so basically the algorithm checks node 3 again. And then we can see that from node 3 to node 4, the distance is 1, which makes this distance 4. So we can erase the 7 here, since 4 is the shorter distance. And then yeah, it keeps optimizing, so it keeps going through the graph. So from 1 to 2 and then to 5. This distance would be 7, because we can't really optimize that. Except we can. We go back to node 4 again, and then we find out there is a 2 here, which makes this distance, shortest distance, 6. So we can erase the 7 here. So yeah, we can check this by going from node 1 to node 5. We can see 3, and then plus 1 plus 2, that's 6. Which is much shorter than, well, not much shorter, but it's shorter than this path right here. So yeah, that's basically how the algorithm works, and we can see that the shortest path from node 1 to node 5 is 6 units long, going through node 1, 3, 4, and then 5. So let's see how an implementation of this would look like in Python. So first of all, we have n. So n is going to be the number of nodes, and here we have 5 nodes, so n equals 5. And then we have a number, say let's do x. So x is basically going to represent the beginning node that we are checking. So let's do 1 since we are doing this, and then we create an edge list. So oops, why does it always do that? So this is going to be a list of tuples of 3 integers each. So we have tuples a, b, and w. So in here, a, b, and w are going to indicate that there is an edge between nodes a and b of length w. So if we look at this graph over here, we can see that from node 1 to node 2, there is an edge that is length 5. So let's write that down. 1, and then 2, and then 5. And then we can just do this for all the other edges. So between 1 and 3, there is an edge of length 3. So 1, 3, 3. And then let's see, from node 1 to node 4, there is an edge of length 7. So 1, 4, 7. And then what else? And then we have between 2 and 4, and 2 and 5. Let's do this in order since it'll look better. So here we can just do 2, 4, 2, 4, 3, I think. Then 2, 4, no, 5, 2. Oops. And then we can finish this by doing from node 3 to node 4 and from node 4 to node 5. So let's write those edges down. So we can do 3, 4, 1, and then 4, 5, 2. So yeah, that's the edge list. And then what we're going to do is we're going to create an array called, or a list called, oops. Why did I write dictionary? Okay. Distances equals. And then we can just do infinity for each node first since we have to minimize the lengths. So we're going to do that by doing this. So system.maxSize. So this is going to be so each element in the distances list. So the nth element in this list is going to denote that from node x to n to node n, there's going to be, well, the shortest length between those two nodes are so we can also set the first node. So basically what this does is same as we did here. So the beginning node, the distance from the beginning node to the beginning node is obviously 0. So yeah. And then we can do for I in range n minus 1 since we're iterating through, or I think we should, do this. Since we're iterating through each element of each node minus the beginning node. So we can do for a, b, w in edges equals the minimum, the minimum between the current distance and distances a plus w. So basically what this is going to do is, so this here, distances a plus w, it's going to check every other node that it is connected to, plus the length between those two nodes. And it's going to see if which one is shorter, so it optimizes that way. It chooses between the current length and the new optimization. So it'll just keep optimizing by comparing between two different edges, I guess you could say. So yeah, this is one of those algorithms that help you go through a graph and construct a shortest path. So yeah, hope you've learned something new today. Goodbye.